Good morning, everyone, and welcome. Thank you for joining the 2021 CTBUH Student Design Competition. Thank you to the jury members who have joined and participated in the process, and congratulations to all of the finalists who are joining on the call. We received about 150 or more submissions, and so congratulations on being one of the top 5 finalists. At this point, I will turn it over to Dan. As the chair member of the jury, who will lead us through the discussion from here.
Thank you, Alec, and good morning, afternoon, evening to everyone. Very excited to be here. So if we could, let's start with CTL Design and the Seed.
Okay. Hi, I'm the leaders of the seeds, 4,000, and my team members consist of Li Jibing, Tan Yuqing, Lim Cheng Hee, and Lau Chi-ying. We are from Malaysia, University Tunku Abdul Rahman, Utah. Okay, good day. I'm Cho Zhaogen, the presenter of the seed. Do you all know how many nature disasters are happening recently? Southern California's Elisa fire, flooding in India and Greece, hailstorm in Australia, and typhoon in Hong Kong and Texas. All natural disasters keep happening because of the rapid urbanization and excessive population growth in the most of the country, which caused the deforestation and the fragmentation of greenery in the most of the city around the world. Cities are overdeveloped, full of the high-density skyscrapers, and people are living in a concrete jungle environment under high pressure. According to our research, Kuala Lumpur is the top 4 most stressful cities in the Southeast Asia. It is because of lacking spaces for relaxing and having a leisure activities in a natural setting. More and more city survivors are surviving from mental health issues such as depression and isolation. Therefore, it is proven that humankind cannot survive without nature in the long term. Are the modern cities development in line with the biological build-up for our bodies and minds? The concept of the seed is intended to build a home for humankind, flora and fauna, to celebrate the nature which it originally belongs to. The proposed tower is located at one of the city's most prime zones, surrounded by the administration and the office tower in the heart of the city center. The farming and ecological park intersect between the tower to form a continuous vertical forest. It will serve as a green crystal to attract local urban tourists and tourists to lead to the substantial improvement in the living quality of the place. And the tower accommodated diverse program of residential, commercial, and farming activities to generate a more economical, sustainable, and living ecosystem in the city. The seed can plug in different cities around the world with adjustable size, scale, and proportions to respond to the site context respectively. Below the tower, the urban linkage is proposed to enhance the biodiversity and activate by the walkable walkway by connecting a people with different direction. Lastly, the modular living pods allow the users to work, stay, and experience the seeds as well as to have a short break and get out the hustle and bustle of the cities. The containers are flexible and adaptable, which can be plugged in or out according to the people's needs. Before the civilization, humankind coexisted with the nature fine. Right now, our selfishness is fragmenting the forest because of the rapid development. Gradually, imbalance of abiotic is the key of the global warming effect. Plugging the seeds is the root idea of our design reformation, as if a seed is planted in the cities, germinate and grow is the root idea in order to simulate the fermentation process in the cities, influence the surrounding neighborhoods and other countries to promote a green, clean, and sustainable cities around the world. As the seeds turn green, it helps to enhance the biodiversity for the balanced and harmonious coexistence between the humankind and nature. The seeds accommodate diverse programs of residential, commercial, and farming activities to form a vertical cities. At the atrium, a mall with a tropical rainforest garden is designed to invite the people to get closer with nature and create a microclimate inside the tower to reduce the dependence and artificial air conditioning. Above the atrium, there is a rainforest recreational sky park. This sky park is created to provide urban wildlife, a place to settle down, and a space for the urban people to rest and relax. Insect Experience Center is designed to increase the understanding of people on the benefits of insects such as the bee and the butterflies. The target is to influence the people to appreciate, love, and learn to live together with the insects. Research and Development Centers is set up to do research on use of the insects and how it can improve our ecosystem, economy, waste management through the pollination in the urban area. The seeds consist of the 3 modular containers, which are experience capsules, Soho, and the living pods for the different user experience. Each module is self-sustainable, self-solar panels, and own farming pockets to empower the consumers to take charge of their daily usage. In today's construction technologies have shown that twisting towers are beyond aesthetic purpose. This type of designs can make a building more aerodynamic and energy efficient. These features has apparently reduced structural construction materials. The seat is designed in a twisted tree-like structure, which is inherently efficient as the form tapers in response to increase the wind loads. The wrapping veins-like blue laminated timber structures extend to the top that form a porous facade that will act as the filter for the urban pollutants in a city. The towers serve as a green lung that is wrapped by the hanging plants to help to refresh the air particles from the urban area. The tower collects the rainwater from the top for the farming purpose, supported by the mist system to sprinkle the seeds for the agriculture and eco-farming around the tower. The towers receive sunlight on modular containers, offset the energy consumed for the light and sound. The wastes are valuable in the biodegradable waste systems for the energy generations as a renewable form of energy to supply back to the buildings. Overall, the farming, green belt, and the landscaping around the tower allow the insects whooping in a different way. Thus, it enhances the biodiversity's connections and the defragmentations of greens. All these solutions overcome the still essentially anthropocentric and the technical concept of the sustainability while moving in the direction of a new biological diversities in the future generation. In the overall, the building with the natural settings enroll with the human feelings and the visual connectivities, as well as the emotions impact, achieving a high degree of the harmonies between the human and nature, and bring a mentally suffering urbanites and a psychological relaxation. Green a city start from planting a good seed. The seed is a prototype buildings designed for the promoting the biodiversity, which not only caters on humans' needs, but also emphasize on the relationship between humans and other living species on the earth, with enhancing the biodiversity and creating a green, happy, and healthy living environments in the cities for the humans, flora, and fauna around the world. Let us look forward to creating a whole new world in the future. Thank you.
And thank you. That was a really good presentation.
Thank you.
So I'm going to open the floor up to my fellow jurors with their questions. Well, I may have some of my own, if I may start.
Sure.
So I would be curious about a couple of things. You know, biomimicry is a very valid concept and one that we do see a lot in architectural proposals. I'm curious about how the structure that you envision for the project would be executed in terms of materials, and what types of materials you expect to form the structure, because you know, while it looks like a plant, I assume that you're not planning to grow this building. So maybe you can tell us a little bit about how it would be constructed.
Okay, sure. initially, for this project in Kuala Lumpur, in Malaysia, we're planning to use a cross-laminated timber as a structures and a concrete as a main foundation material, which able to get easily from the local country, means Malaysia. So it is a very sustainable and it's prefabricated and renewable materials. Therefore, however, according to the site location and the context also, because this project initially we are going to influence around the whole world. Around the whole world. Therefore, we are going to look forward to the location. A different country have different type of materials. The local materials. Therefore, we're also looking for the site location and the context. Therefore, the different alternative material and construction methods of the tower is based on the countries. If in Malaysia, we are going to use the cross-laminated timbers and the RC as the main material. Besides that, we also looking forward to the future materials such as the waste plastic and the 3D prints also. Because in the future, we also, currently we also face that the waste of the plastic is keep increasing. Therefore, probably in the future, the waste plastic may be able to use as the main construction materials for the 3D prints or prefabricated materials of this project.
Interesting. So I'm hearing prefabrication, I'm hearing concrete, I'm hearing waste plastic, and I can't. Did you mention anything about timber or other renewable materials?
Yeah. Timber and the RC are as the main construction material in Malaysia. We are going to looking forward at.
Interesting. And I had one other question, which was about the idea that this was a replicable model in other places. Now, I noticed that, there are lots of plants on this structure which appeared to be tropical in nature, and obviously that would work very well in Malaysia, Southeast Asia, other tropical zones. What would you envision being in a more temperate zone?
Sorry, can you repeat the question?
Like the kinds of plants, for example, that are growing on the structure in a more temperate zone like Europe or North America, would that tropical model have to be changed?
Okay. So means that if located at the rainforest, we are going to look forward at probably the vegetation to linkage between to differentiation the urban landscaping in the city. Then if if the foreign countries such as the Four Seasons there, then probably the sustainable part will be in the different have different kind of systems to sustain the buildings as well. To suit the means that also to suit the local climates. If it's located at a foreign country such as the US, then the project, the models, the prototypes will build it according to the US local climates to suit to the environment the US.
Very good.
One of the main theme of your project is like prefabrication using the container, and then that is pretty similar to the 1972 Nakagin Tower in Tokyo. You know that, right?
Mm-hmm.
And then
Yeah.
Probably you also heard about the future of the Nakagin Tower. Nakagin Tower is currently in pretty bad situation, and then it is scheduled to be dismantled pretty soon. Actually, one of the units is already in the museum in Tokyo, and then another one is supposed to be moving to Paris for another museum. And then if you take a look at your project, it is like a container putting within the structure. And then I'm not sure how it will be managed in terms of the future of that, as well as if you take a look at your project, pretty beautiful project, but in terms of the system-wise, it is difficult to even imagine how those individual units will be serviced. So what is your imagination in terms of the future of this thing compared to the like the future of the Nagakin Tower, for example?
In this kind of aspect, we are going because we are going to use the abandoned containers, something like that. Okay, to reuse it. Then to redesign it, the containers are become a Soho or the living post, those kind of things. Then besides that, the tower is in various is designed in a multiplated in the various direction in consideration. Is it because we are looking forward to the flexibilities and adaptabilities for this kind of aspect. Therefore, we are using therefore the structures therefore the modular, this kind of modular pods can be easily plugged in or out, okay, and delivered via drones and designed for the different function according to the people's need in the future. Yeah, something like that. Therefore, the container able to plug in and out according to the people needs. Yeah, by using the drones delivers to another places. Yeah, this is our imaginations in the future, those kind of things. Then yeah. Okay, thank you very much.
Okay, greeting for everyone. My name is Izham Shah and I'm from University Technology Mara, Malaysia. And today I'm so proud to share about my work. My project entitled Waste Rig, Pudu Eternal Market. So let's talk about Kuala Lumpur, the capital city of Malaysia, which is the basis of my project. It has undergone rapid development in recent decades, as we can see in the pictures. Although many parts of Kuala Lumpur are well developed, but there are the darker side of Kuala Lumpur that remains to be unseen. So one of the unseen side of Kuala Lumpur is Pudu. It was once an economic gem of Kuala Lumpur, which is known for its market goods, such as vegetables and chickens. However, currently Pudu is seen as the dark spot of Kuala Lumpur, with rapid development of surrounding areas, left Pudu with several critical issues that shouldn't be happening in a well-developed country. Due to this underdevelopment, it leads to the issue of poor waste management, migrant-dominated economy, and dirty market. So from a market haven, Pudu has turned to an unfriendly and unhealthy market. So unresolved issues in Pudu. The presence of large wet market in Pudu leads to the first critical issue. There is the improper waste management. This leads to the dirty and unhealthy marketplace that made the local customer uncomfortable to explore the market. The fact that more than 100 bins of bio-waste are generated daily by 1,800 market stalls in Pudu. The question is, the waste is produced every day, but where does it go? The community within Pudu are to be blamed, as the production of the waste are not properly managed by the community itself. However, a solution can be devised to address that could benefit the community and addressing the rising rate of unemployed youth. So there is a need for cleansing Pudu. So how are we going to do it? So from these two major issues, we can create a circular economy. How? First of all, from the waste itself. Excessive waste can be used to generate energy and fertilizer through the bio-waste to energy system. And both products can be used to power up the urban farming, which is created for the Pudu community itself. And then the product from the urban farm, can be sold back to the wet market. And this will generate more bio-waste that can be utilized by the process again. So with the idea of circular economy, we can help Pudu grow on its own waste. So this is the main components of the program. Eternal Engine, which is the bio-waste to energy system. The second one is the urban farming, the platform for farming community. And the last one is the urban market for commercial and market purpose. So the idea of waste rig, instead of we have an oil rig on the sea collecting the oil for energy, we also can have an oil rig on the land collecting the waste for energy and fertilizer. As we can see in the both pictures, there are three parts of the building, which is the first one, the big green pipe, bio-waste to energy system. And then the different sizes of urban farm modular. And the last one is the platform, which is the building building podium. And then at the basement level, we can see there is a waste bank that connected to the neighborhood to collect waste. So the big pipe is the internal engine. The name is internal engine, is the main component of the building, which is a mechanical system that can collect waste from the building itself and from the entire neighborhood to generate waste into energy and fertilizer. As we can see in the diagram of horizontal biomass process, that is the sequences of conventional biomass system. And the right one is the innovation of the sequences into vertical manner. And then the waste collection system are divided into several methods, which is from the building itself, from the neighborhood, and from the nearest market. And to be added on, these features is using the technology of pneumatic conveyor, which is using the pressure to transport waste that can reduce environmental impact. So the second component of the building is the urban farm modular, which is a triple volume stacked farm that's connected to a sandwich of office, R&D spaces, and operation spaces. And this modular is integrated together with the internal engine system to achieve zero waste farming. And these sketches illustrate my initial ideas that highlight the integration of spaces at different levels to form the urban farm modules. So why high-rise? Why high-rise? With the internal energy system, instead of we having farms in different locations, we can have a group of farms that are stacked together that can reduce the usage of land, reduce environmental impact, efficient operation, and of course, close proximity for maintenance. So this is the perspective from the urban market, which is located at the podium. I want to highlight the internal engine penetrating the urban market, which symbolizing the capabilities of biomass system that can circulate the economy in Pudu. And the second highlight is the direct chuted stall, that the hawker can directly toss their waste from their product into the waste bank. So the second perspective of urban market, I want to highlight the usage of cold material as a paneling to absorb odor and freshen the air of the market. And we can see there's a lot of goods fresh because the goods come from the urban farming itself. So the last component of the design is the platform, which is the building's podium. Consists of market and retail platform, a place which embodiment of Pudu informal economy and generating a green economy. And the second one is the knowledge platform to educate the community to a sustainable future. And the last one is the training platform to help youth to start farming. And finally, Pudu pioneering other buildings toward zero waste living with several value innovations such as effective refuse, energy generator, sustainable design solution, farming as potential economy, recycling urban waste, and others. And I want to end my slide with a narrative. The fact that the amount of avoidable food waste generated by Malaysians in 18 days is equivalent to our Petronas Twin Towers filled to the brim. But with the idea of waste rig, we can recycle and convert the waste to energy. If we can maximize the idea, we can reduce the waste to the lowest level. And finally, Kuala Lumpur can achieve the zero waste living. So that is the end of my presentation. So thank you. Thank you so much, CTBUH.
And thank you very much. That was great. Jurors, any questions?
I have a question. Maybe I can start. My understanding from the competition documents was that this bioenergy plant has the purpose that the use of Kuala Lumpur will go back to the agriculture. I don't see the connection. Maybe I don't understand it. Can you explain it a little bit more?
So actually the first one is the issue of unemployed youth, because at the area there is influx of immigrants that control the agriculture economy and the farm and the market economy. So the urban farming is a chance, an opportunity for the youth to learn farming and start their career or business at the market itself. So and the urban farming or the space also teach the youth to do the market without dirty, without waste. So to teach the youth to improve their waste management during the market and commercial activities.
Okay, thank you. Understood.
Okay, thank you.
Hey, I don't really have a question, but I do want to mention that I really did like your project. I like the idea of integrating waste management to a marketplace, especially finding out that that's actually an issue on the sites or nearby sites. And I guess one question could be, you imagine this can be applied to anywhere in different parts of the cities? Is that what you said, or is that what you were showing last? That this could be applied to different buildings, or does it have to be different residential, or does it have to be a marketplace to be able to have this?
Okay, for the idea of waste free, where we can have human, we know that human always produce waste. The waste is unstoppable. So this idea is actually applicable for every building. As an example, office always has the waste of paper, so they can use the paper as the source of energy, because the paper are burned and then to boil the generator. So actually, where is the human? There is a waste, because human never stop producing waste. So how to reduce waste? We have to circulate the waste, because the waste production is unstoppable.
And another question, I guess, you are showing, some kind of infrastructure at the bottom that connects to your building. Is that something could be citywide, or this is just for nearby waste collection? What did you think about that?
Can you repeat again this question? Sorry.
In your competition board, under your building, there is pipes collecting the waste to your building. There's like a infrastructure for that. Is that for, you imagine that for the whole city? Could that be, or is it just for neighborhood? What did you have in mind?
Okay, so there is the automated waste collection system that is connected to the urban neighborhood in the radius of 250 meters, so that the community can toss their waste from the corridor, from the roadside. So there will be a station that the community can educate themselves to throw the rubbish into the waste booth, and then that waste will transport through the AWCS system, which is the pneumatic conveyor system, to the waste bank, which is located under my building. So after that, the waste can go to the process of internal engine. And then the system also applicable for nearest market, because the market always produce waste.
In architecture, the functional as well as performance aspects is very important, but the visual aspect is also very important. And then if we take a look at your project, it kind of reminds us the 1980s high-tech architecture. The difference is you are kind of expressing some sort of different technology. And then also the difference is that in the 1980s high-tech architecture, every technology looking things were outside. So inside was kind of clean, in a sense, plan-wise. That was kind of explained as the benefit of high-tech architecture, even if there are a lot of criticism. But in your case, you intentionally put your mechanism inside. So it is kind of visual expression of that, but potentially could be like bothering people inside, the users. And also the last image of yours was a little bit shocking to me, because you put just the same thing over and over again in the Kuala Lumpur. that means you are trying to, I mean, in terms of cityscape, you are trying to kind of generate the 1980s like buildings everywhere. It is like, I mean, I'm trying to imagine that the Hong Kong and Shanghai Bank by Norman Foster just everywhere in Hong Kong in 21st century. Is this something you are imagining as the future of tall buildings in Kuala Lumpur in 21st century? Just putting just renewed high-tech type architecture throughout the city?
So the high-tech architecture is my architecture style. So I think another building can use their style, their own style to maybe to hide the system. For my project, I want to highlight my system. So I expose the mechanical system because I want to show to the urban, to the community, the power of biomass system that can circulate the waste and reduce waste and turn the waste into gold. So that is my narrative. So if other building want to use the system, they can hide this thing. So maybe they can design more futuristic. So that's my idea. Did it answer your question?
Sure, yeah.
Okay, thank you.
Hello, dear judges. My name is Jun Yi from National Taiwan University of Science and Technology. Han Yu and Jianxin is my team member, and I represent my group to introduce our work for you. Our work is Smart Cube, fast assembling COVID-19 prevention Olympic village. Our life have changed a lot because of COVID-19. COVID-19 is getting worse and worse, and the number of infected people has reached 200 million people, and it has made a lot of difference in our life. So we hope we consider the relationship between architecture and a life model 3D design. At the time when the project is in the creative stage, there is also sporting event that be held every 4 years. The impact of coronavirus has affected the world. The 2020 Tokyo Olympic game will be postponed for 1 year. With the Olympic game coming out a year later, the first issue will be the problem of cluster infection among the athletes. The following chart shows the overall process of athletes' participation in the Olympic Games. The first stage is preparing for the competition. This stage has the risk to take local virus out of country. The second stage is to fly to Japan. This stage can cause infection problem on the airplane. The third, to arrive in Japan to gather to training or competition, there's also risk of infect between players at this stage. Stage 4, athletes are weaker after training and are more susceptible to the virus. The above process are highly risk to infection. So while the Olympic be safe, in particular, the high risk of infection in stage 3 from training or having the competition gave us the motivation to do this project. In order to better reduce the risk of infection, we have reconsidered building a different life model. The graph below is our concept of architecture. On the left side is life pattern of the original estate village. As you can see, it's not just living space and training space create the cluster. Circulation which connects space also increase the risk of infection due to many intersections. On the right side is the concept we put forward. We separate the players' living space and distinguish between different types of training venue. We especially plan to separate each traffic flow independently to prevent the spread of virus and try not to affect the life of players in village. In order to achieve our concept, we have added 2 elements to our architecture: technology and fast assembling. First, technology. We use 4 technology: AR, navigation, big data, and internet to make different change in our life. Next, I will introduce the new life model in detail. First of all, reservation and plan are made using an exclusive app on the mobile phone, including mail, training, and so on. In addition, training menu and diet management, which can be discussed with coach and can be managed digitally. App will use big data and analyzing every moving path and using time differences to avoid the possibility of crew gathering. This picture shows athletes use their mobile phone to go out to train. You can see from the picture that the phone shows the exclusive path to the destination space, and in the circulation area also use the display to guide the athlete more easily and clearly. In addition to single function individual training space, there is also semi-public training track. Projection will be used to give athletes a clearly diagram of runway paths and to display some of training and data together. It can make training more efficient and allow players to know more about their training status. Next, we design the construction model as a fast assembled. Using a module design and fast assembled construction method, the program can be adapted to different competition size and site. We try to reuse and realize eco-friendly concept. The following diagram shows the flow chart of the fast assembling for this program. The first step is fabricate to make various modules. Step 2, transport the complete module to the site. 3, get to the site and deliver it to the crew. 4, unpack and categorize various modules. 5, construction. Precast steel structures are used to form the main structure of building. 6, stack the cell module into it as designed. Detailed design. There are 3 spaces connect from the inside to outside. Their interlayer is as the living units. All use a single person suit can effectively achieve the effect of epidemic prevention. The median layer is epidemic prevention circulation space, which design all the traffic flow, including the stairs, elevator, and so on in a modular manner. By combining technology with automatic door, controlling its opening and closing result in a single exclusive traffic flow. The outer layer is training and activity space, including the retraining room, basketball crew, a swimming pool, and other different training categories of module. It's also including the air park so that occupant can try to relax at the enclosed hotel. Then how can players get to everywhere in building? First of all, players will use their phone to make appointment and arrangement and start from the resident unit, then pass through the median layer, epidemic prevention circulation space. This layer use big data analyzing an app to guide the path to achieve the effect of epidemic prevention. Finally, the third layer of training and activity space, as these need to arrive at their scheduled space within specific time. Function module. We design training module for swimming, basketball, retraining, rock climbing, horizontal bar, and more. We use balance, proportion, rhythm, and so on mentioned it in the principle of design and consider the formation of elevation of building by the division of circulation and sport categories. This is elevation of the building. You can see training scenes of some internationally renowned players from the outside of the building. Swimming, rings, sport climbing. We want to design an Olympic athlete village in response to the post-epidemic area of sport events. And we hope to propose innovative way to solve the difficulty or crisis common to the world. Thank you for listening.
And thank you for presenting. Definitely tackling a lot of very immediate and prescient issues here with all of these projects. It's nice to see. If a little daunting, with looking at all the problems that we are facing. Jurors, questions?
I have a question. So thank you, it was a good presentation. So I believe we have a good approach to user experience in terms of technology and architecture. And I like the idea that you have used the modular construction approach. But my main question for your project was what happens after the Olympics? So do you have an idea? Because we have the Olympics in every 4 years and always in different countries. So Do you have an approach?
Okay, according to the problem after the Olympic game, because the project is using a module design and a fast assembled construction method, the project will be adapted to different competition size and sites. After the Olympic can be quickly assembled and reused in other sport events, reused to achieve the concept of environmental reuse.
So you will use for different sport events in the same way?
Yeah. So the project will be reused and reused according different competition for.
Where? So in which country?
Which country?
Have you ever thought about that? So do you have a specific location in your mind?
Yes, our site, the actually site we imagine is the Tokyo and Asset Village now. It was already built there, and we set in the site the same with the Asset Village now in Japan. Yeah.
Okay, so it will be used for other things as well, for other sport activities after Olympics.
Yeah.
Okay.
I think we're,
Sorry.
yeah, I think we're wondering, you know, if it gets disassembled, would it be moved to, say, another Olympic city, for example, Beijing 22, or wherever the next Olympics is, or will it be reused as something else on the site? Because, you know, it's a problem with Olympic villages. They tend to be, they tend to go to waste. The cities always promise that they will be converted into something useful for the general citizens, and then oftentimes it falls short of that. So I think that's why we're asking this question.
Yes.
Sure, I mean, but still, I really like your idea of the design, which is kind of even just the visual very provocative. And then I have a quick question about your modular construction. Prefabrication is pretty good, and that's the reason you are kind of considering that. And then prefabrication sometimes can kind of limit the design because of the characteristics of the prefabrication. But in your case, you kind of use all different for the form for the prefabrication. But in your drawing, I also noticed those are all different types of the forms are also overlap with the normal grid. And then I was wondering, when we saw your transportation schemes, you are kind of making very awkward form things, you know, in terms of the transportation, right? In terms of the generating kind of beautiful form with all different forms for the prefabrication, that is good. But in terms of transportation, that is really not practical if you have all different forms. But in your design, I also noticed the normal grid overlapping with the different forms. So I was wondering why you put that grid, and have you thought about just even if your final form is all different forms, your transportation module could be more modular. In that way, yeah, in that way you can generate the all different forms with the modular things, and then your prefabrication idea could be even much enhanced. What do you thought about that? I mean, so one question is why you put the modular, normal orthogonal modular grid over the all different forms, and how that is not implemented in your transportation of the prefabrication module?
I think this problem, just judges say, is I agree your opinion, and our team thinking is just we separate the different categories of sport, and we want the elevation of the building is more beautiful. So we designed the different shape. Maybe will create some problems of transport too much or something else, but I think it can be dissolved, or it can be studied after this competition. Yeah, it will be the future. Maybe it's the good suggest for us to do.
Sure. I mean, this is nothing you need to defend. Actually, this is just some discussion about your beautiful project. So I enjoyed it, and then thank you for sharing that beautiful project with us.
I actually do see the the grid system being applied to the modular on the facade. So I can't see how that might be integrated. So I think there is a thinking behind that. Yeah, thank you for the presentation, because we really like the idea of using modular units in a different forms, like different than what we used to see. I guess one comment would be, you know, to everyone's point, this would be hard to transport elsewhere. Maybe you could suggest something to be reused within here, because you already have all the systems in place, you know, circulation and all that. This could be a new building for new functions. So I guess that's one thing to think for you guys. But overall, very, very cool project. Thank you.
Thank you.
So, hello, my name is Mariana, and I'm studying at the University of Belgrade, and I'm the only member of my team, so I'm going to present to you the influx design. The design is located at Belgrade, Serbia's capital, in the municipality of New Belgrade in the Block 17, near the Danube-Sava confluence. New Belgrade represents an authentic urban and architectural whole, designed and constructed using modernist concepts and strategies. New Belgrade was once one of the largest construction sites in the world and largest construction area in the former Yugoslavia in terms of size, space, and number of apartments, buildings, and apartment blocks. Initially, pavilions were built with the enthusiasm of young people at work actions, but that type of construction stopped very quickly. In the 1960s and 1970s, Yugoslav experts caught up with the most prestigious planetary builders and created a new part of the city according to the highest urban and architectural standards. This experimental settlement was constructed using innovative technology, prefabricated structural system with installation of pre-stressed concrete elements, which was called IMS. The influx design focuses brain drain phenomenon. Substantial migration of able-bodied, highly educated, talented, and creative young individuals searching for a better pay or jobs under better conditions causes Serbia to lose qualified people. During the crisis of the 1990s, Serbia lost a significant part of its best potential workforces. 5% of the total population emigrated, which 91% were people less than 40 years old. Even after 2000, the situation with the migration did not improve, and every 8th highly skilled individual leaves Serbia. The adverse effect of human capital flight caused concern about the nation's development, and emergent situations such as the global pandemic of the COVID-19 spotlights the lack of qualified human resources, giving it a new perspective. Our design proposal, Influx High Rise, is a co-living for young professionals and a part of the program to curb the outflow of encouraging skilled technicians and scientists to remain in Serbia or motivate young educated people trained abroad to return or become transnational in terms of brain circulation. The social environment is considered the key reason for brain drain, both in general, like the lack of the opportunity, political instability, repression, economic depression, or health hazards, and on individual levels, like the influence of family, professional preferences, and career ambitions. Respectively, the building design was guided by the social sustainability and quality of life, or QOL aspects. Social sustainability is a process for creating sustainable, successful places that promote well-being by understanding what people need from the places they live and work. Social sustainability combines the design of the physical realm with the design of the social world, infrastructure to support social and cultural life, social amenities, system for citizen engagement, and space for people and places to evolve. Symbolically, the design is located in New Belgrade, a part of the city initially in the 1950s, populated by students living in the pavilion dormitories of Student City. The building, positioned at the attractive location in Block 17, aims to offer new opportunities and better living and working conditions that attracts talents. Previous was challenging because in order to use the space most efficiently, tall buildings design sometimes causes the loss of focus on the user and his social aspect. The qualitative analysis of the behavior of the focus social group, which was conducted through survey and interviews, provided understanding of what people would like to experience in co-living. The goal was to make better design decisions when creating new sharing spaces by acknowledging people's preferences and concerns before designing the project. Consequently, the design intention was to achieve the comfort of individual housing inside of a tall building. And regarding the urban design, the aim was to distribute the same concept that exists within the building itself through the outside space. This flexible spatial organization and distribution of contents balance the needs of users for individual, shared, and common spaces, while spontaneously encouraging connectivity, socialization, and the creation of community relations. As illustrated in this mood board, the intention was to design spaces that will ensure social, physical, and psychological well-being, considering changing societal and production circumstances due to technological development and the digital economy. Our goal was to research the design possibilities of using increased computer capacities to raise the initial modernist understanding of architecture as a set of prefabricated discrete elements or modules to a new level of previously unattainable detail, materiality, structure, and aesthetics. Previous ideas were developed through a repetitive modular design approach in formal, structural, and technological terms. Generative design strategy based on computational open-ended generative systems was applied for creation of spatial structures. Respectively, design exploration was done using a graph grammar compositional algorithm that generates building out of the modules or building parts by applying defined composition rules or connection between modules and constraints stochastically. The structure is manifested through two organizational categories. First one would be spatial contents in terms of living, work, education, and leisure. And second one, level of socialization in terms of individual, shared, and common spaces. Model, by its form and organization, represents continuous communication between these categories. The functional organization is illustrated by a group of models, which alternatives are repeated through the whole building. The result is a dynamic spatial organization, which is complementary to the idea of creating communities that also share values, interests, and philosophy of life. Influx provides socially sustainable places that will motivate students to achieve greater academic and professional achievements, while providing much needed encouragement for talented individuals to reconsider staying in Serbia. The emergent structures, made of autonomous, modular, and repeated processes of composition, facilitate self-assembly robotics fabrication strategy, increasing the efficiency and economy of the fabrication, transport, and construction time. The proposed application of automated design and construction technologies gives a hint at the potentials of digitally intelligent architecture. The use of 3D printed concrete panels in which limestone and calcined clay replace cement for materialization is an homage to New Belgrade's concrete architecture, while also meeting current sustainability criteria. Focusing on human user, social sustainability occurs when the formal and informal processes, systems, structures, and relationships actively support the capacity of current and future generations to create healthy and livable communities. Socially sustainable communities are equitable, diverse, connected, and democratic, and provide a good quality of life. And thank you for your attention.
Thank you very much, Mariana. I'd like to give the floor to the jurors for some questions.
I really appreciate your kind of idea of trying to enhancing social sustainability in tall buildings. That's really one of the most important issues we need to resolve as a people who are interested in the development, further development of tall buildings. So I really appreciate it. And then one of the things I found out is that your idea is really good, and then your drawings and everything trying to achieve that is really good. And two thoughts. One thought is still you need tall buildings, walkable, but one of your drawings, which shows showing your design concept of social sustainability about the horizontal plane of the building, but your core looks too small. I mean, social sustainability naturally, just let me finish it, okay?
Okay, sorry.
Social sustainability requires kind of, the reason why we are considering social sustainability in tall buildings is because this is kind of vertical stacking and segmented. So we need kind of more horizontal connections, but still we need kind of functional building, and then your core looks too small. So I hope you can just make all the systems more workable kind of scheme. And then what if you can actually build similar modules surrounding your building as a proposal, and then keep connecting those things to even enhance your social sustainability idea to next level, and then also expand your design ideas further, because your design idea can be really expandable based upon your design kind of concept, right? So
yes.
Not limiting your design within single building, but just to keep perhaps connecting with different heights, and then keep expanding about the building itself as well as the social sustainability issues. And then still trying to make your building solidly workable with all the systems considered.
So that's a really good proposition. Thank you. Well, this structure can be used actually as a prototype of these kinds of buildings that promote social sustainability. And yeah, in the extension of this research, we can use it as a prototype that could be placed all over in the world, because this is a problem that is placed in Belgrade, Serbia, but it's not a problem that is only problematic there. It's a global problem in a lot of countries. So yeah, I appreciate your
So one idea is kind of keep connecting those towers based upon your design concept, or if you can just put only single tower you design, and then just thinking about only connection path to the existing building, perhaps.
Okay.
As an idea of just keep developing your research in terms of social sustainability, because I think that's really important parts of the theme we need to further develop as a people who are interested in tall buildings.
Thank you. I also try to extend that concept that exists within a building to urban context in terms of the outside space. So we have those shared common and individual spaces in terms of, I don't know, libraries or canteens or anything that a student or a technician needs inside of a building, to place that also in the outside space in terms of amphitheaters or leisure and recreation spaces. So
one recommendation I would have had, looking especially because you have some generative design alterations studied, even though you have such a integrated idea and I think a nicely laid out building, what stand out to me as a weakness in your project was that it was very repetitive, which was almost similar to in the previous images you showed us in the previous housings. Those housing has the issue of being so similar to each other that they have less characteristics. I mean, of course, your building looks different than any of those buildings, but if you have your building, 5 of them next to each other, they are so repetitive. And I really mean that it's repetitive floor by floor. It looks stuck up. But I'm intrigued to see that you actually did some generative proposed massing studies where you have certain parts are just vertical elements versus horizontal, rather than everything being so horizontal. I guess that would have been one thing to add to your building massing, is to have some kind of different movements in your building to kind of give a little bit more characteristics and maybe staying away from repetition, even though it is needed to, build anything, easily. But that's the challenge, right? That's the challenge of we all have not being able to, meet those both needs. But overall, we really did appreciate your approach of social sustainability, because that's something that we all miss and don't even think about often enough, because then that's almost literally the most important aspect of us building these buildings, to bring people together and hopefully give them opportunities that they didn't have in a typical environment. I don't think I have any other comments.
One remark from my side, sorry. One remark from my side, I like it, this concept. It has a clear reference to a city and a district in the city. But I'm wondering, does this type of construction achieve a stop to the brain drain? This is my question. I don't know, maybe you thought about. And a question about the facade. Do you have an idea how to create a facade? I think we have to cover this building. Do you think about?
Well, to answer your question about brain drain, firstly, the intention was to create spaces that are socially sustainable. So the first thing was to make questionnaires or polls with the students and potential users of this space. And it was a challenge to create, in a way, a generated structure as it is, to translate those needs to space, because you cannot put aesthetics and space in the mathematical algorithm, but you can put models. So it was, in a way, translation between users' needs to architectural space, and then to model, which was integrated into mathematical algorithm. And I think that while having a conversation with these people and students, and I'm a student as well, the key to staying in this country, the problem was that we don't have resources or jobs, or the student dormitories here are not in that good of a condition. And maybe if we gave the students, before they finish their studies and want to look for jobs, if we gave them enough resources and socially sustainable places to live, work, and study, maybe that will be the beginning of canceling the problem that is globally there. And in terms of facade, the idea was to not replicate, but do a facade in the spirit of the urban context, which is concrete. But concrete is problematic because in the long term, it emits carbon. So, and the cement is problematic in the mix, because I wanted to do the 3D printed facade panels. And the idea was to replace the cement, Portland cement, with calcined clay, which is 3 to 4 times better in regarding the emissions of carbon. So I hope that answers your question.
Okay, thank you very much.
One thing, if I may add, Mariana,
Yeah.
is it would have been really nice, or make your project stronger, to have some environmental studies, like solar studies and daylight studies, to see how much of that we actually get inside your building or your units. Because you have these social spaces, it would be nice to see how much of a natural daylight or sunlight comes into your building, or how your building responds to this. Your building has the same facade to every side of the building, which doesn't means that it's ignoring some of the sustainability aspects of design, because we need to have different approaches for south versus east or west or north.
Of course.
I think having that study done could also add more value to your project.
Of course, I completely agree. It was just beyond the scope of this research in fact of time, but thank you so much.
Of course, thank you.